Hi, this is Turtle, and this is my video write-up for Hacking Time for CSAW 2015. This is reversing 200. Okay, so you only get one file here. It ends with an NES extension, which ends up being a really big hint later on. But if you go and download this file, and I've got it here, just close this one out. Okay. And we just open it up in plain good old-fashioned notepad. And we scroll down through it, we can just kind of get a look to see what it is. It doesn't really give us too much information except for this. There's a bunch of strings that end up being in this game for Nintendo. And there's also this big passage from, this is actually from The Time Machine by H.G. Wells. This is just to throw you off. It's just padding for the game file itself. So let's close this out. And before you can open it up, you actually have to download an emulator to play it. And if you go to FCCE Ultra, this is the one that I use, it has a pretty good built-in debugger and hex editor. So you can probably use any one you want, but I decided to use FCE Ultra. So let's go to the emulator, let's load it up, and let's open the ROM. Okay, hacking time. Alright, we're in the grid. So looks like it was the ROM after all. Mystery solved. Okay, the first thing I'm going to do is I'm going to set the emulation speed to turbo because this thing is really slow. And you just keep pressing A. It's just prompts going through A. And then it will come to this grid log on. It actually tells you what to do. It says overfill the buffer, press A. You can keep pressing A. I've got it set to turbo, so it's going to fill it up. And you'll eventually get to this password screen where it says enter the password to disable the lockdown. Okay, so I'm going to go ahead and put in just a couple of characters, a couple of A's all the way across. I believe there's 24 characters in this password. Okay, and then if you hit A, it will submit it and it will say access denied. Okay, so looks like that password didn't work. That was a good shot. Okay, so if we go to the debugger and open up the hex editor, the first thing that you'll notice is that this string of A's that we put in here, you can see it right here in the memory. It's just out in the open. And if you go down through the RAM itself, it's in there a couple of times actually. Here, and here, and here. And if you keep going all the way down, you'll see that the text earlier that was displaying on the screen, and some additional stuff that comes after this. But after that, it's just that padding file. We can just ignore. Okay, so the first thing we're going to do is to break this down. I'm going to set a read on this first character. I'm going to set a read breakpoint, and what that's going to allow us to do is when we hit submit and it reads this memory address, it's going to pause the game and it's going to tell me what line of code in assembly that's running. So I'm going to hit A, and then we'll see a break. And here you go, load A. This is the memory address. This is Y. It uses Y as a counter, as an offset. And I think if you go down here, you'll see Y starts at 0 here. But if you go through this code, just line by line, and it does a bunch of weird stuff. I'm not gonna go over that. There's some XORs, and you can actually follow these back to their memory addresses that it uses to try to obfuscate the password. But if you keep going through, eventually you'll get to this line right here, where there's an XOR, and then there's a store command. It will get down through here. And once you get to the store command, it's actually storing a value in this 1E value with a Y offset. Okay, and like I said, Y in this case is used as a counter to store the values in subsequent areas of RAM here. So this 1E actually corresponds to this value right here, is 87. And if I hit run, okay, close that out, hit run, access denied, and this 87 value had something written to it. And if you couldn't see that, I can actually go back to here, change this first value. Oh, let me just pause that, hit run. Okay, change this first value, hit submit. You can actually see these values changing. Yeah, every single one of them changes. So making one change to this password changes all of these. So that's kind of another hint to how it works. Okay, so what we're going to do next is I'm going to right click on this value. We can delete this one. I click on this value here. I'm going to add another read breakpoint. Okay, and then I'm going to submit this again. It's going to break when it reads this value, because like I said, the one before was just a store. This is a read on here, and it reads the first memory address. This whole thing right here, by the way, is written every time you update these. It just goes to yeah, that's right. Okay, so close that out. If you go through this line by line, the first line here, you'll notice it sets y. Remember, this is a counter to 0. And this line loads the value of 5. That's the hex value in right here. Okay. It loads that hex value of 5 into the accumulator here, A. This is your accumulator. And I'm not actually going to not do these because since this one right here is going to be a branch if it's not equal to 0, which is what the value that's pulling from here with this LDA. If this value is 0, then this won't jump. So this will jump only when it's not equal to 0, which is, 5 is not equal to 0, go here, and this address right here is just the part where it checks it and it'll display, not accessed. Okay. Instead, if it doesn't do this, it'll increment y, our counter, and then down here, it will actually just re-loop back up to here again. Okay, and since y is being incremented, it won't be 1e this time, it'll actually be 1f. And then the next time it'll be 20, and it will just keep going through all these hex values as long as they're equal to 0. Okay, if they're not equal to 0, it won't go through them. So what we can do is if we select these values here and we know they want them to equal to 0, we can actually zero them out. I might go through them all. Zero them. Okay, and I think that's the last one. Okay, and then I'm going to select them after I've zeroed them. I'm going to freeze their values because I don't want the emulator to be able to write to these because I want them to stay at 0. So this will just force them. It'll say, hey, just don't mess with these values. I want them just to be 0. And if you do that, and we go back to the Duggar, let's turn this off, hit run. Okay, it actually shows lockdown disabled. We've beaten this. But if you go through your hack, I've got it, thanks, save the world, says your actors will be rewarded, submit the lockdown password to score points. Okay, so I don't think the lockdown password is DAAAA. Okay, obviously it's not because we forced it with these zeros. So what we can do is we can reset this. Okay, and then I'm going to unfreeze these 0 values here. All right, let's just go through this again real quick. Dictation fault. Okay, back to the password. Okay, so we know these have to be 0 in order for this to go through. So what values make this 0 will make these values 0. So the values up here. So what we can actually do, and an easy way to do this, is just delete this one, is if you go to the second character, which would be 1f here, because 1e is going to be the start of the one that it changes. If you go to the second one and we set a read breakpoint, okay, and we can set one to this first one as well. Add read breakpoint, okay, and we set this to A and this one to A, and I run it, okay. you'll notice that the 1E, the first breakpoint, this one right here, goes off. Okay, if I hit run, oh look, this second breakpoint, 1F, it never even fires. So what's happening is it's checking the password, but since this doesn't equal 0, it doesn't even bother to check it. Just does the 1. So we just had to figure out whatever makes this 0. And a really easy way to do that is just to remove this one, only check the second one, and then what we can do is we can toggle this first one until it breaks. So I'll just keep going through. Okay. Okay, there we go. Now it just broke. It set the flag. So I know that this is our first character because it's equal to 0 here, because we use the break. And all we have to do is just keep going through one by one. Here, I'll do it. I'll just set this one here. We'll set another break at read breakpoint, and then we'll remove this one. We'll go through here, hit run, access denied. Just go through them all. Okay, there we go. It broke. Okay, so we can delete this breakpoint. We can add the next one in. You can actually you can add a couple of them in at a time, because it won't go to the next one unless it equals 0. So just add a couple of them. Okay, and then hit run. Okay, let's go to the first one. Just keep toggling through the letters till it breaks. Okay, it's good. Turn that one off. Hit run. The next letter. Okay, and you get the idea. If you keep going through this, doing every single one of these memory values, eventually they'll all equal 0. And I have a little save state I'm going to load to. It'll look something like this. And hit run. Okay, it'll look like this. You'll notice that they're all 0 here, with the exception of the last one, because I haven't changed that one yet. I fired it right when I got to the TR. And once we submit this, with X as our last one, at 0, and it's going through these breaks. Let's go through these breaks. We'll say lockdown disabled. You got it. There's the password. Okay, and then unfortunately it doesn't tell you the password again, but you have it in RAM, so you can just copy it right out of here, and then you could submit it. But CSAW's over, so not really gonna help you. Again, this is Turtle. This is a write-up for hacking time. Thank you.